Hi folks, welcome to day 27. Today we're going to be going over section 5.5, which is all on multiplying and dividing functions. So remember, you're going to refer back to your chapter 4 work when you were multiplying and dividing polynomials for some review of this same content, but we're just applying it to functions in general rather than just polynomials. All right? So when you're multiplying polynomials, you have to multiply coefficients and you add exponents, right? And when you are dividing, you divide coefficients and you subtract exponents, all right? Technically, I will say for this division piece, that only works for simple cases, dividing by like one term, right? So if we had like 5x to the 1/2 plus 3x to the 2/3, we know that numerator can't be simplified any because we can't combine those since they're not like terms, but maybe those are being divided by an x to the 1/2 as well, all right? What I'm saying is these divisions will only happen with a single term on the bottom. All right, we're not going to be doing any binomial work with division. All right. So remember that we're still going to be using function notation in this video. So if I'm referring to things like the function f or the function g or f of x and g of x, just remember that I'm referring to two different functions. All right. I will also make a note here that the most difficult part with multiplication and division is with the exponents. Because remember, since these are all rational exponents, they are all fractions. You're going to have to add and subtract fractions. All right? Your calculator doesn't typically have a fraction button that looks like this. All right? Usually you'll have to say parentheses 1 divided by 2. Parentheses. So just make sure that you're being really, really careful when you are adding and subtracting fractions on your calculator or adding and subtracting fractions on paper. Okay, regardless, you don't have to use a calculator, but you're of course welcome to. All right, let's go ahead and just do a couple examples. So if we have f of x is 3x and g of x is x to the 1/5. I'm going to walk through how to find f times g. And since it's a times, I'm going to just use that little dot. All right? So f times g. Well, f, I have 3x. All right, so I have 3x times g, which is an x to the 1/5. So I have 3x times x to the 1/5. So I know that... Okay, I'm multiplying. So I multiply coefficients and then add my exponents. So I have a coefficient of 3, and then g doesn't have a coefficient. But remember, if it doesn't have a coefficient, if there's nothing written there, that means the coefficient is 1. So I have 3 times 1, and then I have x, and then my second step is to add exponents, right? So I'm going to go ahead and add my exponents. So I have... From g, I have that exponent of 1/5. And then from f, remember, if there's no exponent, you assume that it's a 1. So I have 1 plus 1/5. All right? Remember, though, when you're adding fractions, you actually need to have a common denominator. And since 5 divided by 5 is the exact same thing as 1, I'm going to replace that 1 with a 5 over 5, or a 5/5. All right. Now I can go ahead and evaluate. 3 times 1, well, that's just 3. Then I have x to the 5/5 plus 1/5. Well, 5/5 plus 1/5 gets me 6/5. All right, so f times g gets me 3 to the 6/5. Now let's talk about f divided by g. So f was 3x and g was x to the 1/5. So I have 3x divided by x to the 1/5. Now, if you aren't following the two steps, it's going to look confusing, but that's why you have to remember. With division, you always divide coefficients and then subtract your exponents. All right? Divide coefficients, subtract exponents. Well, 3 divided by 1 is just 3, all right? But we have 3 over 1, all right, which we know is 3, which we'll get to in our simplification step. And then we have x. All right, so we took care of all of those. But then we have an x and then an x to the 1/5. Remember, that's an x to the 1 and an x to the 1/5. So I can rewrite this as, instead of 3x over x to the 1/5, I can rewrite this as 3 over 1 times x to the 1 minus 1/5. And just like I did last time, I'll replace this 1 with a 5/5, and you get 3 times x to the 4/5. All right, because remember, this is a minus sign. All right, and that's f divided by g. So you follow those same steps from multiplying and dividing polynomials. You follow those same steps when multiplying and dividing functions. Now, I will make just one quick note about domain, because there is some pretty big domain changes from polynomials. And honestly, that's the biggest change that you're going to be working with, other than adding and subtracting your fractional exponents. So your domain, if you have any odd roots. So remember, roots are determined by the denominator. So like an x to the 1/5 or an x to the 2/3. So if you have any odd roots, the domain is that x is all real numbers. All right, or you might see it as the double-lined r. Okay, so any odd roots, anytime you have a odd number in the denominator, you have your domain is all real numbers. If you have an even root, though, right, like a 1/2 or like 1/6 or anything like that. All right, so any even roots. Remember, an even root, right, next to the 1/2, well, that translates into a second root of x, or what you'd call a square root of x, right? So these turn into like they're similar to square roots because they're even roots. You can't take the square root of a negative number. So your domain is that x is bigger than or equal to 0. All right? So all of your x's have to be bigger than 0 because you can't take the square root of a negative number or any even root of a negative number because it's imaginary. All right? And the only other thing that you need to keep in mind with your domain is during your division. All right? In division problems, since you have an x on the bottom, all right, for all division problems, your domain must include that x doesn't equal 0. So if you have a division problem with an odd root and x doesn't, you would say, instead of saying x is all real numbers, you'd say x doesn't equal 0 because you cannot divide by 0. If you had an even root, instead of saying that the domain is greater than or equal to 0, you just say greater than 0, because then it can't be equal to 0. All right? So that's all you have to remember for your domain. Multiplying and dividing is just like multiplying and dividing with polynomials. Multiply and divide coefficients, add and subtract exponents. All right, that's all I got for you today. Best of luck on your assignment.